Hi, my name is Yongkai. I'm a good reader for this group. My members is Pan Ziqi, Lin Fangyong, Ahmed, and Gillian Lai. I'm going to present the Bayesian decision theory. In the real life, we are probably face general risky decision problems. The probability of the natural state is given as known conditions. The probability which is revised by using the additional information is known as a posterior probability. Bayesian decision is a decision method which uses the information to estimate the posterior probability according to the Bayesian probability formula. What is Bayesian decision theory? Bayesian decision theory refers to the statistical approach based on trade-off quantification among various classification decisions based on the concept of probability, Bayes' theorem, and the cost associated with the decision.
The Bayesian decision theory solves the pattern recognition problems. Bayesian decision theory is a statistical decision method that can be used to solve the pattern classification problem, and it involves computing the probability that an input pattern belongs to each possible class, and then selecting the class with the highest probability. The features of the Bayesian decision theory is using the probability distribution to describe and process data make it possible to deal with uncertainty. And it calculates the probability of each possible class and choose the class with the highest probability as the class of the project. And all the attributes participate in classification. This approach makes Bayesian decision making more accurate because it utilizes all available information.
So what are the advantages of Bayesian decision theory? Bayesian decision theory allows for a combination of prior knowledge with the observed data in the decision-making process, which can lead to more accurate decisions. Besides, by incorporating loss functions that weigh the cost of different outcomes, Bayesian decision theory enables the consideration of different levels of risk, which allows easier management of risk and decision-making that minimizes potential losses. On top of that, Bayesian decision theory is also capable of handling situations with uncertainty or imperfections in the data. Bayesian decision theory also allows constant updating of decisions, provided that new data gets collected and analyzed, making it possible for decisions to be revised and refined gradually.
And now for the components. Prior or state of nature. Prior probabilities represent how likely each class is going to occur. The state of nature is a random variable. If there are only two classes, then the sum of priors is probability of x1 plus the probability of x2 is equal to 1 if the classes are exhausted. Given a prior information, we decide x1 if the probability of x1 is greater than the probability of x2. Otherwise, we decide x2. Class conditional probabilities. It represents the probability of how likely a feature X occurs given that it belongs to a particular class. It is denoted by the probability of x1 given y, where x is the particular feature. And also it's the probability of how likely the feature X occurs given that it belongs to the class Y. It is also known as a likelihood. Posterior probabilities. It is the probability of occurrence of a class A when certain features are given. It refers to the updated probabilities of each possible event or class after we observe the evidence or data. And here's the formula.
Now I present the limitation of Bayesian decision. First, to accurately represent the actual distribution of data, the sample number must be sufficient. When the sample size is small, a priori probabilities Bayesian decision will show a significant divergence. Second, it cannot be differentiated when each category has a distinct attribute weight. Thus, in Bayesian decision, it requires the condition that each attribute value be independent of each other. Next is the conclusion. The statistical method known as Bayesian decision theory is based on the quantification of trade-off between different classification choice based on the notion of probabilities, Bayes' theorem, and the expenses related to the decision. Thank you.